Hi, in this video, I just want to do an example of computing the 5-number summary for a data set that we obtained. It wasn't in order, and we just want to compute these values from what we learned from a previous video. So below is a sample of 26 trials of rolling a fair six-sided die until a 2 is obtained. So imagine you have a six-sided die, right? We'll put a little die over here, right? And you start rolling it, and you roll and roll, and the first time you have to roll it 13 times before you get your first 2. And so you try this experiment again, you start rolling and rolling your die, and eventually, let's make a little better die here. Eventually, the number you get is 2, but this happened after 11 trials. In this case, your third time, you got 2 after 2 trials, and so forth and so on. So we did this 26 times. I kept rolling a die until we obtained our first 2. So this data set is not ordered. The values here are actually the order they were collected in. So, the first time was 13, 11, 2. So the first thing I'm going to do to determine the quartiles and determine the values in the 5-number summary is to order my data from minimum to maximum. So that's what I've done right here. So here are the 26 data points in total and in an ordered value. So in this case, n is even. Recall n is 26. So the median is going to be between the middle 13th and 14th ordered data points. So since there's 26 data points, I made it so that there's 13 on this line and 13 in this line. So the middle point between the 13th and 14th point is 5. So if we count in here, just to make sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's 13 is the value 4, and here's 6, which is the value, the 14th value. And when I average 6 and 4, I get 5. So the median is 5. It's the value such that 50% of the data values are less than it and 50% of the data points are greater than it. The position of the first quartile, we use that formula n plus 1 over 4. So we put 26 in here and we compute that value to be 6.75. So the first quartile is between the 6th and 7th ordered data values. So let's go ahead and count. 1, 2, 3, 4, 5, 6, and here's 7. So it's in between. We're going to interpolate between 2 and 2 to get the first quartile. But because 2s are both in position 6 and 7, then we can just say, hey, quartile 1 is 2. So 25% of the data values are less than or equal to 2, and 75% are greater than or equal to 2. Next, the position of the third quartile, we use the formula 3 times the quantity n plus 1 over 4. I put 26 in for n and we get 20.25. So in this case, the third quartile is between the 20th and the 21st data point. So I knew this was data point 13, 14, 15, 16, 17, 18, 19, 20. So this is data point 20. This is data point 21. So the 20.25 means it's a quarter of the way between the 20 and 21st data points, and a quarter of this length is 0.25. So what we're going to say is it's between 10 and 11, which is 10, and then a quarter of the way, or the quarter of this length, is 0.25. So Q3 is going to turn out to be 10.25. Now the interquartile range is just the difference of Q1 from Q3. So here is the IQR. we're saving the best to last or easiest to last. The minimum data value in this data set is 1, and the maximum data value is 29. So the range of this data set is max minus min, which is 28. So in the next video, we're going to take that 5-number summary and actually construct a box plot. So if you've been excited waiting for the box plot, it's going to happen in the next video. The box plot does display the 5-number summary, and also we can glean extra information from it, the skewness of the data, if we have outliers, etc. So I hope this makes it more clear how the quartiles are computed, and again, that they're cutting the data set into quarters. So the next video will be on a box plot, so if you're interested, I hope you join me for another video on that. And until then, I hope you're doing fine, and we'll talk again soon.